Hello everyone. Let me introduce myself. My name is Daniil Pryimak. I'm a site reliability engineer at Virex. Thanks for having me today. I'm really excited to share my practice knowledge about FinTech application monitoring based on Azure infrastructure. A few words about Virex product. Our payment platform pioneered the seamless integration of crypto and traditional currencies to support multi-currency accounts, currency transfers, and exchange services. Virex has a global footprint with 8 offices across the globe, nearly 4.5 million registered users we have, and availability in more than 130 countries and territories. Considering the multifunctionality and high user activity, one of the most important goals for us is to have a clear and relevant picture of application performance and, of course, user experience as a whole. What's on our agenda today? The first one is infrastructure monitoring. In particular, we'll point out how Microsoft services and tools are involved into monitoring process and what advantages and limitations they have. Depending on their limitations, we will cover other tools we use that meet our needs. Next one is business monitoring. Um, Besides of performance monitoring, we also have a talk about how business metrics monitoring is organized. By business metrics, I mean the workability of verification, crypto transactions, card payments, and every single action that user can make inside the application. Um, also, monitoring process. In this part, we will briefly describe the alert lifecycle from being fired to postmortem analysis. And we will share the experience of our custom solutions we were forced to develop because of crypto technology specifics and the already existing services that doesn't meet our needs. Okay, let's begin from infrastructure monitoring. Let me discuss on why is monitoring important. We should consider the following things. The multifunctionality of financial technology application requires a complex Azure infrastructure that we already have. Besides, we should keep in mind that the application is a global payment platform with more than 4 million registered users. That means we have a big volume of transactions and millions of events every day. To provide the best user experience, our highly load system needs to be 24/7 control. Here is our monitoring targets regarding infrastructure monitoring. The more things we see, the more things we can control actually. To have a clear picture of system performance, our main target is to monitor the maximum of possible number of components in our cloud. Scale sets. Without proper monitoring of scale sets, we can't get a full tracking of our cluster. Also, monitoring of microservices. As I already mentioned, we have a multifunctional application, so the entire product is separated by microservices which are interconnected and work in a single cluster. And of course, to catch all the unexpected system behaviors, we set up the alerts for every scale set instance and each service possible. To better understand the size of infrastructure, let's talk about what we are dealing with. 350 resource groups, 12 active Azure Service Fabric environments, more than 150 virtual machine scale. 50 applications with up to 370 microservices in each environment, more than 250 storage accounts, and 280 load balancers. Okay, let's talk about monitoring tools, especially in particular Microsoft ones. We use Azure Monitor for performance metrics and custom metrics, which is developed in application insights, Powershell, and Power BI. Let's go into the details. Azure Monitor. It provides us with different insights on various services. We have the ability to set up autoscale for scaling resources. Also, we can set up alerts regarding service health and security and many more. We also use customizations for business monitoring. As I already said, that is application insights. Also, there is an option to set up the integration with third-party products. Currently, all metrics from Azure Monitor are being forwarded and set up in Grafana. This gives us to combine several monitoring tools and alert management in one place. We will talk about Grafana a bit later. Powershell. In common, Powershell provides a large number of models to work with Azure. In our case, it gives us the option to cover aspects and metrics of the resources that are sometimes hidden or hard to find, such as various different customization tools. Power BI. Power BI provides the option to visualize and efficiently manage business metrics into charts, spreadsheets, diagrams, etc. But we have a limitation here. It doesn't let us to monitor real-time metrics. However, this is a great solution to create the statistics for big periods like weekly, monthly, and even annual reports. One interesting thing to share. For Power BI, we are using separated database, which gives us the option to minimize the load on production databases. So, we can retrieve the only required data. And when we are talking about big reports, as I said, they are being triggered only in time when the system is not loaded, especially at night. Okay, let's move to the third-party tools we use for monitoring. Rafana, Prometheus, Splunk, and other custom solutions. We will talk about them later. Okay, Rafana. The main advantage of Rafana is the opportunity to combine all data sources in one place with proper alerting management. According to that, this is our main visualization and alerting tool for all components we need to monitor. All performance and the big part of business metrics are visualized and being under control there. Prometheus. Prometheus is a monitoring solution for recording and processing any purely numeric time series data. It scrapes metrics from instrumented jobs either directly or via an intermediary push gateway for short-lived jobs. Also, it can store all scraped samples locally and runs rules over this data to either aggregate and record new time series from existing data or generate alerts. Grafana or other API consumers can then be used to visualize the collected data. We use Prometheus a lot, and we use several Prometheus for different environments. What are the advantages we see of using Prometheus. The first advantage is local on-disk time series database and optional integration with remote storage system, which is actually really cool and we currently use it. Also, Prometheus can discover scale set automatically with Azure configurations. Azure Service Discovery configuration. It allows the newly created scale set to be automatically discovered and named as it is in Rafana and be monitored already. Also, many services expose metrics and it's not that hard to create them for all applications. Okay, what about exporters? We use a basic exporter like Windows exporter. It was developed by Prometheus community. It's used to monitor Azure infrastructure. It's deployed on each instance of virtual machine scale set, and this service collects metrics that were previously set in a pre-deploy. Also, the interesting thing, we use a process collector in Windows exporter. Our microservice exists on an instance as a process. So, getting metrics for processes allows us to monitor them. We get information specifically for services such as its performance metrics, CPU time, working set, virtual bytes, input-output operations. Display, also we have a display of when the process was started on a particular instance, and many more useful things. To sum up, we are able to see the performance consumption of service on particular instance of scale set. The next one is quite similar to Windows exporter, but it's made for Linux virtual machines. It's Node exporter. As you can see, it exposes the same performance metrics, and it's deployed on every instance we have on Linux. Splunk. We use Splunk to ingest all the logs from all services. That provides us to detect the errors and expected growth of these errors, delays in processing time while completing particular type of requests, monitor the part of business-related monitoring such as crypto transfers, exchange transactions, card payments, and all user activity. For all that, we are able to set up the alerts, which are processed by our own tool and sent to Microsoft Teams and or Grafana alert. Let's take a brief look to another exporters we use. CAdvisor, it's been used only on Linux virtual machines. It provides the understanding of the resource usage and performance characteristics of Docker containers on a virtual machine. Black box. The black box exporter allows black box probing of endpoints over different protocols. Next one is Horizon. It is implemented on our site to control the Stellar network and our Stellar node. It provides Prometheus metrics from all the operation API endpoint of Stellar Horizon network, such as number of operations, number of payments, sum of payments, number of account creations, and many more metrics. The next one is Nexus. This exporter is being integrated to monitor our repository manager that organizes, stores, and distributes artifacts needed for development. Okay, let's move to the next section. This is a security monitoring. We also keep our security under control. Using the PowerShell scripts, exporters, we are able to catch the unexpected actions made to sensitive resources. For example, just a few of them, it's changes to network security groups, changes to firewalls, also suspicious logins to virtual machines, and suspicious queries to production databases. Okay, let's move to another part of my presentation. Let's talk about business metrics monitoring. Here are the key targets we consider for business metrics monitoring. We need to monitor anything related to customer experience and what can affect it. Transaction processing, performance of its processing on all microservices associated with that type of transaction. Also, performance of all user actions. It means exchanges, deposits, withdrawal, verification, verification of email, verification of device, and so on. Also, we detect suspicious activity. The next one, we monitor third-party services performance and their health statuses. And the last but not the least, blockchains. We use custom metrics, which are stored in Azure Monitor metrics to visualize amount of actions that customer performs. It includes sign-ins, exchanges, password resets, email confirmations, and phone number confirmations. The monitoring is implemented by using Azure Monitor metrics. It's actually custom metrics made by Application Insights. Top-ups. Customer can add balance to their account using their own credit card issued by any other bank. We monitor the processing time on our services as well as performance of our third-party API related to top-up. We also monitor ratio of successful transactions and total amount of them in dollars. We monitor such activity using Splunk logs and dashboards. Okay, Pyrex cards. Customer can order our own card and make transactions only using their crypto or traditional accounts balance. We are taking care of the exchanges if the transaction is performed in not the same currency, automatically and internally. We monitor the amount of cards ordered, amount of ISO messages processed, and processing time. The monitoring is implemented by using custom application Insight metrics, as I already said. Sorry. The next one is cryptocurrency deposits and withdrawals. Customer can move their digital assets easily from and to their Wirex accounts. We monitor the status of such transactions and monitor the errors related to these transactions or their delays while processing. The monitoring is implemented using by Microsoft SQL data source in Grafana. It means we use the database made for Power BI. It helps us to understand the global image and global potential issues. Of course, it's not real time, but it's quite helpful, especially when we are talking about the last 24 hours and later. Verification. Customer must verify their identity to use our application. We monitor the amount of successful verifications and failures, what caused a failure. The monitoring is also divided by regions. Thus, we can understand what region is affected. The monitoring is implemented as well by the database, which is made for Power BI. It contains useful spreadsheets that we can retrieve directly to Grafana. The next one is suspicious activity. We also monitor the suspicious activity related to customers, which includes, but is not limited to, some of them: frequent logins, frequent reset password attempts, device confirmations, phone number confirmations, and other actions. Also, we monitor the abnormal amount of requests on our API in common, globally, and for particular user. Using Power BI functionality, we created special reports to see suspicious financial activities as well. Okay. As some functions of our application directly depend on such platforms, we need to monitor them in all the ways possible. Almost any third-party platform we are working with has a status page. Several of them also have an API with endpoints that we can probe. But with some of them, we are also exchanging heartbeats. Using Blackbox Exporter, we can also check the endpoints of these platforms periodically. We also utilize the monitoring of heartbeats. If there is no heartbeat received or sent, it signals about possible issues. Obviously, for such a big amount of metrics, tools, and services involved, it is really important to properly set up the monitoring process. Now, let me share our experience of monitoring process management. We are constantly working on improving the monitoring process, which includes alerts creation process. Developers, SRE team, DevOps teams are working tightly together to get everything possible, every possible service and action monitored and to be alerted once there is an issue. The alerts are created when the new service is implemented and deployed, or as after postmortem actions. SRE team is the first line of defense against system outages or issues. Let's get to another one. Okay, the alert. The alert is the start point of the potential issue. Let's describe the alert resolution process. We have several types of alerts based on their severity. The first and the main, it's a critical severity. When it happens, a call performed to an on-call engineer using OpsGenie. Other alerts may be sent as a simple message in Microsoft Teams to relevant channels to persons who are actually responsible for the service where the alert happened. It can be forwarded by Rafana alerts or Splunk logs alerts directly to Microsoft Teams. Once the alert is acknowledged, the engineer performs playbook actions. We have playbooks that are written for each alert with the following details: how to analyze the issue, what might cause it, and actions to resolve it with a detailed description. If the issue cannot be resolved by the engineer, they escalate it further on developer that wrote the service or on development and operations team, if the issue relates to infrastructure, of course. Once the alert is resolved, engineer performs a post-analyze and write a postmortem with such fields and topics as short description of the issue, timeline to catch every timing, every moment, and every idea that a relevant person is proposed for fixing the incident, actions to resolve. This is a short, brief description of timeline where the actual ideas were involved in the future for fix deployment. Lead up. This is analyzed sequence of events that happened and leaded and caused the alert firing. Impact. Impact describes who was impacted by this alert. It can be users from different regions, or it's not about user experience, it's about infrastructure. The next one is detection. This is the person who initially catched the alert or unexpected system behavior. It can be not only SRE team, also the support team, or developer. We are always cooperating together to find unexpected system behaviors. So in this field, we match the person who identified that something goes wrong. Response. This is a list of every single person who was participated in the alert and for the whole incident resolution. Root cause is like an advice how to prevent this in the future by describing the initial reason why the incident happened. When the postmortem is written, not only related teams perform action required to avoid such an issue in the future, but also the playbook is written in order to resolve the issue. Of course, if it's repeated. Thus, we can resolve the potential issues that we already faced with in the past. We can solve it faster in the future. Also, every 2 weeks, our teams, SRE team, development operations team, developers, are conducting a meeting related to all production issues that appeared in the period of 2 weeks, and are discussing future actions and relevant tasks status about ongoing fixes for the past incidents. Okay, let's go to final part. It's custom solutions we were forced to develop because we didn't find the service or tool that cover our needs. So we created our own. Well, here is third-party statuses exporter, wallets exporter, Office 365 status exporter, and Splunk webhooks handler. We have created an internal tool that parses status pages of these third parties and exposes metrics based on information parsed. It notifies us about scheduled and ongoing maintenances and any opened incidents on their side. Using Prometheus in Grafana, we can create alerts to notify the responsible person. Wallets exporter. We are also dependent on blockchains, and we need some external monitoring for this. We monitor the balances of our internal wallets, time of latest successful transactions on these wallets on the blockchain, and we can monitor the current block on the blockchain. This is just to be prepared for potential and future hard forks that usually happens really too often. The monitoring of Office 365, 365, as you wish. We have created an internal tool that parses Office 365 status and expose metrics. Well, it notifies us about any ongoing issues on every product of the service. Using Prometheus and Rafana, we can create alerts to notify the responsible person. Again, by OpsGenie. Also, we monitor the difference in prices in tickers with some of the popular cryptocurrency exchanges like Binance, Bitfinex, OKEx, just to make sure that our rates, our internal rates, are similar to their. Splunk webhooks handler. After the transition to Microsoft Teams, we faced with the issue related to Splunk alerts, as there is no native action in Splunk to send information to Microsoft Teams. Unfortunately, the proposed plugin on Splunk site didn't work as we expected. Because of that, we decided to create our own. So let's go a bit into the details about this application that we made for handling these Splunk alerts and forwarding this in Microsoft Teams. When the alert is fired in Splunk, it sends JSON payload to our application. The application analyzes the alert, matching it with information in our alerts database by particular field, which contains alert name, and sends the information with needed fields to Microsoft Teams to the needed channel by incoming webhook, which actually can be set up in Microsoft Teams for every channel you have. Also, we made the fork of Flower. This is a salary monitoring tool just to add label with alert name to every alert processed. It allows us to create alerts that are already escalated by OpsGenie. Okay, that was it. Thank you for your attention. I truly hope you will find the information helpful in your future monitoring implementations. Have a good day.